This is the fourth and final video on this 4-page energy note packet. We're going to go to the fourth page here and take a look at this question. You have to find the work now using a plot. Well, once again, work is F times D, or F cosine theta D, but there's no angle, so we'll say it's F times D. How do you find F times D with a plot? Like we've been finding anytime you're trying to find the multiplication of a y and x axis, you simply find the area. So if you've got a plot and you want F versus D, you want to find the work, use the area, which is, in this case, 1/2 base times height. We have a triangle. Base is 5 meters. Height is 3 newtons. Half of 15 is 7.5 joules or newton meters. Now, since this is just one significant digit and this is one, I guess we really should answer 8 joules, but we'll leave it like that. If you ever really got the real thing on a test or a quiz or an AP, we'd have the right significant digits. Let's look at this one here. Net force acts on a particle only in the x direction. The magnitude of that force increases from 0 to 24 newtons at 3 meters. So what do we have? A plot looks like this. F versus D. And you're starting off at 0. It increases linearly from 0 to 24. So that's 24 at 3 meters. So after 3 meters, you're at 24 newtons. This unit is newtons. This is meters. And let's see what happens next. From 3 to 8, it's a constant force of 24. So it goes 3 to 8. Might not be the prettiest graph that I make here. 3 to 8, it's 24 newtons. And then it decreases linearly to 0 by 13 meters. Yeah, this is pretty terrible, isn't it? That's linear, and it's 13 meters. But that is not a great plot. I apologize for that. All right, so determine the determining the area under the graph of the x versus x plot. So what is the work? Well, you've got the work is simply the area of the triangle, the rectangle, and the triangle. So the work is just the area. So this triangle, we'll call it A, B, C. That's 1/2 base times height plus base, times height plus 1/2 base times height again. And so the work is 1/2, the base is 3 meters. The height is 24 newtons. Then you've got that rectangle. That base is 5 meters. 1/2. Oh, wait a second. It's not one. No, it's the base times height. So there's no 1/2 in there. So it's the base is 5 meters. And the height is 24 newtons. And the triangle, 1/2 base. Let's see, 8 and 13. 8 and 13, that base is 5 meters. Keep the units in there, and the height is 24 newtons. So this is half of 24 is 12. 12 times 3 is 36 joules. Let's see, that's 120. 120 joules. Getting pretty sloppy. Half of 24 is 12. 12 times 5 is 60 joules. 180 plus 36. Let's see if I got it right. 180, see, because 60 plus 120 is 180, plus 36 is 216 joules. With two significant digits, does it turn to 220? Let's see how I did. See if I got it right. Yep, 216 turns to 220. Very good. And that is how you use plots to get work. Notice I left out the cosine because if they don't provide the angle, well, what heck could you use cosine theta in the well, the force acts in the x direction and the object moves in the x direction. They could have said, yeah, they even say it moves in the x direction, so the theta is 0, and cosine 0 is 1. So that's how we can leave out the cosine theta, because the force acts in the x direction and the object moves in the x direction. Cosine theta is 0. So I probably should have said that in the beginning. And that is the last page.